All right, let's keep going here. Complex or imaginary numbers. Let me give you a little historical background to imaginary numbers. Um, well, here, let me open this up. First of all, let's imagine what are the numbers we've dealt with up to this point. We've dealt with what's called real numbers. Real numbers are split up into complex numbers and rational numbers, okay? The rational numbers, the most basic rational numbers, if you will, are the natural numbers. So the natural numbers are like your counting numbers, one, two, three, dot, dot, dot. And then they're a subset of the whole numbers. The whole numbers are zero, one, two, three. So this is kind of the historical development of numbers, right? They're like, oh, we can count things. And then they discovered, oh, we can have nothing, zero. Let's call that zero. We have nothing of something. And then they expanded it. Hey, I want to go into debt. Let's call those the integers. -3, -2, -1, which also includes all the whole numbers. Dot, 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 right? Those are the integers. And then they discovered the rational numbers. We can have fractions of things. So a rational number is anything of the form p over q, where p and q are integers. So like -1/3 or 1/7 or -3/4, right? Or just 7. That's also a fraction, if you will, right? 7 over 1. So these are all real numbers, right? These natural numbers, whole numbers, integers, rational numbers, they're all considered real numbers. And then there's the complex numbers. That would be like the square root of 2. Square root of 4 is not, because that's 2. That belongs over here with the rational numbers. That's a natural number, whole number, integer, rational. But if you can't have a clean number from it, like square root of 7 is another um, I'm sorry. Oh gosh, I called this complex. I meant this to be, sorry about that. This is the irrational numbers. Sorry guys, irrational numbers. Another irrational would be like pi, 3.14. So in decimal form, 3.14159, blah, 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 right? The decimal does not repeat a pattern, but it goes on forever, right? E is another very famous one. We'll look at the irrational E later in this course. But in decimal form, the rational numbers like -1/3, that just is -0.3 repeated, right? So it's repeating, or like 2/5, right? That's 0.4 in decimal form. So these rational numbers will either repeat a pattern or they'll terminate, right? They'll stop. So all of these numbers, again, are what's referred to as real numbers. These are all real numbers. Well, then Carl Friedrich Gauss came along and he said, you know what? Why can't we solve this? Why can't we think of a number that makes this true? Because if you try to solve this, you get x squared is -1, and we square root both sides. So I'd have plus or minus the square root of -1. Well, this -1, square root of -1 is not a real number. It's not in any of these. It's not a natural number. It's not a whole number. And it's not an integer, rational, irrational. It's none of these. It's not a real number. So Gauss said, you know what? Let's expand into what's called the imaginary numbers. And let's create a whole nother new number system. And let's call the square root of -1, let's call it I, the imaginary number. So he expanded this and they said, let's call any complex number anything of the form a plus bi, where a and b are a real number. And so there's these pure imaginary numbers like I, which is the square root of -1, right? Or 3i, or -7i, or square root of 2i, and so on. Anything with an I, anything of the form bi is a pure imaginary, okay? But that's what Gauss did, right? He expanded it, and now he's made it so that you can solve equations of the form x squared plus 1 equals 0. So let me erase this real quick, and then let's do some math with the imaginary number and imaginary numbers. So what you want to remember is I is the square root of negative 1. Okay, so if you see a square root of negative 1, you replace it with I. Well, what that means is if you square I, right, in other words, you square this, both sides here, square that, that'll just pop out negative 1. So I squared is just negative 1. Okay, so you can simplify powers of I, right? So let me go through a few here. So I squared would be negative 1. What would I to the third be? Well, what you want to do is you want to write that as I times I squared, because I squared is negative 1. So I to the third ends up being negative 1I. Let's do I to the fourth. You want to write it as I squared, and then how many more I squares do you have? Well, you have 2 of those. I squared squared. That's I to the fourth. So this is negative 1. I squared is negative 1 squared. Well, negative 1 squared is 1. So I to the fourth is 1. What would I to the fifth be? Let's keep going with this. I to the fifth. You want to write it as how many I squareds do you have? I don't want to take 3 because that's I to the sixth. So don't take 3, take 2. There's I to the fourth, and I have 1 more I left over. So that's negative 1 squared I. Well, negative 1 squared is 1, so this is 1I. So I to the fifth reduces to I, or simplifies to I. Let's keep going. Let's go I to the sixth. That's I squared to the third, right? I squared is negative 1 to the third. So it's negative 1 times negative 1 times negative 1. I to the sixth simplifies to negative 1. Let's do one more, last one, I promise. I to the seventh. I squared, I can take 3 of those. There's 6 i's, and I have 1 more left over to make 7 i's. So this is negative 1 to the third, and then times I. So negative 1i. I to the seventh is negative 1i. And let's finally do I to the 38th. Let's do this first problem. I to the 38th. That's I squared how many times? Well, 19 times 2 is 38, and I don't have any other i's left over. So this is negative 1 to the 19th. Well, negative 1 to an odd power is negative 1. So I to the 38th is negative 1. I to the 359 would be, let's see, I squared, let's see, 179 times 2 is 358. So 179 of those, that's 179 times 2 is 358. So I have 1 I left over. So this is negative 1 to an odd power times I. So that's negative 1I. So I to the 359, negative 1I. I to the 233, what would that be, you guys? There's your work for that one. You take I squared to an even power, 116. So negative 1 to an even power is positive 1. And you got an I left over for all 233 i's. All right, so any complex number can be written in this form, a plus bi. A and b are just real numbers, okay? So, for example, 4 minus 13i, a plus bi. So the real part of this is the 4. The real part is the 4. The imaginary part, the imaginary number, is the negative 13 part, right? What about 18i? Well, how do you write 18i in that form? Well, that's 0 plus 18i. So here's the real part. There's the imaginary part, 18. Now let's go ahead and simplify and write this appropriately. The square root of negative 144. Well, before, when we were only working with the real numbers, we didn't think this was possible. But now that we've expanded this to the imaginary numbers as well, right, the complex numbers, anything of the form a plus bi. And by the way, every real number is a complex number, like 7. 7 is a complex number because you can write it 7 plus 0i. We just never wrote the plus 0i before, but it is a complex number. right? And of course, so are these pure imaginary numbers 3i. Let's go ahead and do this now, because we can, now that we've expanded to the complex numbers, we can work with the square root of negative 144. I'm going to write that as negative 1 times 144. In other words, negative 1 times, and I know 144 is 12 times 12. So let me write that this way. That's square root of negative 1 times, and I know the square root of 144 is just the 12. And the square root of negative 1, remember, I is the square root of negative 1. So this is I times 12, but we write that as 12i. We write the real number first. So this next one, the square root of negative 15, I'm going to write that as negative 1 times 15. Now 15, I can't do anything with that, but the square root of negative 1 is I, so then I just write I root 15 or root 15i, either one of those. Preferably the bi, so root 15i actually is proper for that. Let's do square root of negative 80. So that is negative 1. 80 is 8 times 10. So 8 is 2, 2, 2. 10 is 2 and 5. All right, here's the I part, and I've got a square root of 4. 2 comes out, square root of 4. 2 comes out, and then I'm left with a 5 underneath. So it looks like 4i root 5. Is how you want to write that. All right, how about the square root of negative 162? Why don't you guys try that? Go ahead, check your work on that. You guys should get 9i root 2 once you factor that. Let's do this next one. Square root of 4 minus square root of negative 16. Well, square root of 4 is 2 minus, now I'm going to write this as negative 1 times 16. I know the square root of negative 1 is I. I know the square root of 16 is 4. So this just ends up being 2 minus 4i. This one down here would be, this is negative 1 times 9 times 10. Square root of negative 1 is 9. Square root of 9 is 3. I'm left with 10 underneath. I can't do anything with the 10. It's 2 and 5, right? So 2 minus 3i root 10. Let's put this one in our standard form here. 6 plus, let's see, I got negative 1 times 3 and 36. 3 and 36, or 3 and 6 and 6, in other words, would be 108. So I comes out. I got an I got square root of 36, so I got a 6 come out. I'm left with a 3. This is all over 36. So 6 plus 6i root 3 all over 36. Well, that's a common denominator. So I got 1/6, right? That's 1/6. Same thing here, 1/6 plus I root 3 all over 6. So 1/6 plus I root 3 all over 6 is your preferred form there. So there's your A part, and the B part, BI part is that root 3 over 6. 3 plus squared, I'm going to break that down. Negative 1 and 9 and 5. This is all over 21. I know the square root of negative 1 is I know the square root of 9 is 3, and I'm just left with a 5 underneath. And then this is a common denominator, so 321 plus 3i root 5 over 21. So I got 1/7 plus, right, that's 1/7. This is another 1/7. I root 5 all over 7. So this is handy when we're solving quadratics, which have imaginaries as well. So we had the quadratic formula where ax squared plus x squared, come on. Oh, come on. Let me try that one more time, you guys. If we have ax squared plus bx plus c equals 0, then we know from our quadratic formula x equals negative b plus or minus square root of b squared minus 4ac all over 2a, right? So what we have here is 3x squared minus 4x plus 6 equals 0. So our a is 3, our b is negative 4, and our c is 6. So let's go ahead and plug that into the quadratic formula to solve this. Negative b, negative 4, plus or minus my b squared minus 4. My a is 3, and my c is a positive 6. This is all over 2 times a. And so then this becomes, clean this up, so 4 plus or minus a square, negative 4 squared, that's 16, minus, what is that, 12 times, I got to 72, minus 72. So I guess 16 minus 72 is a negative 56 all over 6. Well, we can do this now because we have imaginary numbers. So negative 1 times 56 goes into, what is that, 4 and 14. Square root of negative 1 is I, square root of 4 is 2, and I'm left with a 14 underneath. This is all over 6. And then notice that both of those will go into 2. So this will become uh, 2/3 plus or minus I root 14 all over 3. And we'll do this last one together. We'll do one more here. If I have anything of the form ax squared plus bx plus c equals 0, so I can identify a, b, and c. So a is 4, b is negative 12, and c is 13. I can plug it into my quadratic formula, and if you love to sing the song, you can sing the song. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. I will never do that again, but now you've heard it. Hopefully you can remember the quadratic formula there. So x equals negative b plus or minus square root of b squared minus 4 times a is 4, c is 13. This is all over 2 times a. Negative times a negative is positive. I got 144 minus 16 times 13. I got 208. minus 208, that's a negative 64. And so we got 12 plus or minus, I'm going to write that as negative 1 times 64. I know the square root of negative 1 is I. know the square root of 64 is 8. So we got 12 plus minus 8i all over 8. In other words, 12 eighths plus or minus 8i over 8. Well, 12 and 8 both go into 4, so that's 3 halves plus or minus 8 over 8 is a 1i. So 3 halves plus or minus I, and that should help you guys get started on CR15. Thanks for watching. See you next time.